All right, so we're going to quickly review how we told if a particle was speeding up and slowing down. So if it's speeding up, that's a little bit different from velocity increasing and velocity decreasing. Speeding up happens when velocity and acceleration have the same sign. The object or the particle is slowing down if velocity and acceleration have opposite signs. Again, that's different from the velocity increasing, velocity decreasing. That I look at the derivative of velocity, which is acceleration. So speeding up, slowing down. The tricky part about these, let's say we have velocity vector 2, 3, and acceleration vector -5, 5. So in this case, I look at it in terms of the x component and the y component. The x component is slowing down. The y component is speeding up. So I look in each component. Since the x's have opposite signs, it's slowing down. Since the y components have the same sign, it's speeding up. So it can go in terms of either way. I gotta look at the x's and the y's. One could be speeding up, while the other one's slowing down, or they could both be speeding up, they could both be slowing down. All right, so given the position function, find the velocity and acceleration at time t equals 2. So velocity would be equal to the derivative would be 6t squared, 2t. Acceleration, derivative of that would be 12t and 2. So what I want to do is I'm going to add something to this. I'm going to say when t is -1, is it speeding up or slowing down? And t is 1, is it speeding up or slowing down? So this is kind of extra. I've added this. So velocity at -1, let's plug in a -1. What would that be? Oh, I forgot the +1 here. Oops. So 6t squared plus 1, this would be 2t. So if I plug in -1, I get 7, -2. Acceleration would be -12, 2. So in this case, the x component is slowing down, and so is the y component. It's slowing down in both aspects there. For t equals 1, v of 1 is 7, 2. A of 1 is 12, 2. So in this case, it's speeding up in both components. All right, to find the speed here. So speed at time t equals 2, given the vector value function. Speed is the magnitude of velocity. So I need to find velocity. In component forms would be 3. And then what would that be? -2t e to the -t squared. V of 2 is equal to 3 and then -4 times e to the -4, which I might go ahead and rewrite as 3, -4, e to the 4th, like that. So the speed is the magnitude of velocity, the speed at 2. So when time is 2, I went and plugged in 2. It makes finding my speed easier. Speed is equal to the magnitude of velocity plugged in at 2. Be the square root of 9 plus 16 over e to the 8th. And with the calculator, I got 3.00089. So that would be the speed of the particle at that moment, which is the magnitude of its velocity vector. It's like how long the vector is. So the longer it is, the bigger that distance formula is, the faster it's going. The shorter, the slower it's going. All right. So we can go ahead and start this next one. Actually, we're going to just skip those. So I'm going to make the next video about the total distance traveled. So thanks for watching this video. If you have any questions, ask me next time I see you in class. Bye.